Arduino or some or any other microcontroller. And yeah, and again we are going with the display devices, like display device types and how they are useful in our hobbyist project or daily day projects like that. And yeah, at the end we will jump into the hands-on demonstration. Okay, so coming to the okay, so coming to the motors. So I think everyone is know about what is a motor, like basically how a motor works and like what is its function basically. So basically, a motor is a mechanical, or you can tell it as a electrical come with mechanical device which makes a movement, or yeah, which creates a movement by applying electrical energy to it. So that's the basic. So if you see here, there are currently there are different and several types of motors that are available in market. And basically all the motors, like what are the motors available on the market, is classified into four main categories basically. One is the DC motor, the general purpose motor, which we will use in daily life application and also in the toy cars, small toy cars or medium sized cars, anyway, whatever the like this the general motors that is available. And these are general motors that we learned in our school days also, like which basically works on your Faraday principles. Just by applying a current across its terminal, it will start to rotate due to the change in the flux in the change in the flux in the in the magnetic field. And the second type of motors are called as servo motors. So these are like what you can say, like advanced motors, which has a precise control over its rotation. Like an example, in the in your normal DC motors, you can't control the rotation, like I say, in a 360 rotation you want exactly a 10-degree rotation, or exactly 20-degree rotation, like that. Your normal DC motor can't, like you can't control it, because it's directly control. There is no any control device or any other embedded system inserted with the motor to control that precision, like controlling the movements. Whereas in the servo motors, if you see in the sideway picture here, you can see the anatomy of the servo motor. So basically, the servo motor consists of a DC motor, like a general DC motor which we discussed, and a gear system. This gear system is actually not necessary in every aspect, since the servo motors are available in various form factor. Like an example, whatever the servo motor you're seeing here is a tiny small servo motor which has a torque of 9 G. Means it's capable of providing torque of 9 GCM, or kgcm, or gram cm, like that. So for these type of servo motors, the actual motor should be very small. So if you're picking up a smaller size motor, their speed and torque capacity will be very low. So in order to achieve the rated capacity, or in order to achieve a rated speed or rated torque, I will introduce a gauge system in between. So which will be where there will be a change in the gear ratios, which directly and indirectly affects your speed and torque of the overall motor. And if you see in the picture, there is one knob type of component which is named as which is called as potentiometer. So the use case of this potentiometer is to uh, precisely measure the angle of rotation that your motor is doing. For an example, you want to rotate your motor for 30 degree, like essence 30 degree. So you will provide a particular signal to the servo, which is controlled and sorry, which is used to control the DC motor through this embedded board. The small microcontroller board will be present. So this board will it will provide some signal that helps the motor to rotate 30 degree. But we don't know whether the angle of rotation is very accurate, or whether there will be any sort of offsets or any other anomalies that could happen. So that those things and all we don't know. We will just provide the signal externally. So in order to tackle those things, they will add on additional potentiometer which is connected to the main main shaft. So this potentiometer helps in calculating how much degree of rotation that the DC motor is providing. So like in case this potentiometer is just a variable resistor whose resistance varies with respect to change in the knob, correct? So when the knob changes, the particular resistance also changes. So this microcontroller will will keep on monitoring the resistance of the potentiometer, and it will correlate the resistance value with the angle of rotation. So it's like a complete loop, like closed system. So using this system, the servo can able to achieve the accuracy or precision in the angle of rotation. So this is how the servo works. Okay, so basically these servos are highly used in robotics applications or in some other mechanical arms or some other application where there is a precise accuracy or precise angle of rotation is required, like that. Okay, so coming to stepper motor. So okay, so when you consider servo motor and stepper motor, the purpose is almost same, because even the stepper motor is used to rotate to have a precise rotation over rotation by defining the angle, like how much what is the degree of rotation that you require. But the main difference is the servo motors uses a mechanism called as the PID mechanism, like proportional, integral, and differential mechanism. So that's a closed loop system. Whereas whereas your stepper motor magnetic uses some other mechanism where uh, okay, it uses a different mechanism where the angle of rotation is defined by the pulse that you are giving to the stepper. So if you see in the right side of the stepper motor, you might see the anatomy where there is a rotor behind which there is a magnet, like there is a magnet present. These magnets are like very small, like for an example, in a normal like a standard size stepper motor may contain up to uh, uh, maybe in several hundreds of magnets. So those magnets are aligned in such a way that each magnetic rotation will form a what do you say will have a particular degree. Like I say, a single magnet is placed. All those magnets are placed in such a way that if you want to move the shaft for 5 degree, so you need to pass the pulse to push two magnets. Like for example, if you take one magnet rotation as 2.5 degree. So basically in stepper motors, so everything the rotation is considered based on the step size, or they can tell step angle. Okay, so apart from that, one more major difference is the servo motors. If you think if you see the servo motors will have a gear systems. Most of the servo motors will have a gear systems because of because of smaller magnets are used, like smaller motors are used in most of the case. Whereas in the stepper motor, if you see, there won't be any gear systems. Most of the time there won't be any gear systems. Here the motors are used, very bulky motors are used, and stepper motors are basically used for what do you say heavy load applications where you want to pick or move or rotate any particular object which has more weight, like in terms of kgs, okay, in terms of kg. Okay, the last type of motors is called as BLDC, like brushless DC motors. Okay, so these are the these motors are highly used in drones applications where your RPM should be more, like it will be in terms of 10,000, minimum of 10,000 RPMs, like that. But if you see the anatomy, or if you see the working principle of this BLDC motor, these motors working principle will be exactly opposite to whatever the motors that you are seeing here, like a DC motor or stepper motor. The main difference, or yeah, the main difference will be, in your normal DC motors, you will have a component called as brushes, which basically converts your alternating current into a directional current, and allows your motor to spin in one direction, in only one direction, depending upon your battery terminal. Whereas in this PLDC motors, there won't be any brushes. Like the complete shaft will be rotating by the change the current, basically an alternating type of current. And one more major difference is here in this normal DC motor, you will be having a permanent magnet called as stators, and a rotating coil called as armature. Okay, so where your magnet will be permanent, and because of the due to the apply of current across the terminal, the armature gets magnetized, and cuts the magnetic field of the permanent magnet, so it starts rotating. So this is how a DC motor starts. Whereas in BLDC motor, the permanent magnets is a rotor, uh, can be called as a shaft, like rotating shaft, which will be surrounded by a permanent stators, like windings. Like if you see here, there is the armature coil, right? So those type of armature structures will be fixed across, fixed in the body. Whereas your magnet, which is fixed in DC motors, will be placed on the rotating shaft. So here, due to the change the current applying to the windings, your motor starts rotating due to the change in the flux generated in the system. Okay, so by doing this method, one of the major advantages, you can achieve higher RPM, like higher RPM rate in terms of 10,000 RPM load, 10,000 RPM to like more than 20, 30,000, 40,000 RPM. Okay, so that's why these BLDC type of motors are highly used in drones and aviation applications, where you require a higher RPM rate and higher thrust rate. Okay, so this is the brief example of type of motors. So again, there are some other types of motors that are available, but those motors are like highly used in heavy applications, where you are like, what do you say, where your type of interfacing will be completely different. Like these type of motors can have a direct interface, not a direct. There will be some I/O bridge in between, but you can easily, you can easily connect it. You can easily connect it just by mating the terminals. Whereas there are some industrial based motors where you, like the primary source of the motor will be like a complete three-phase AC supply, that is coming from your coming from the industrial power hub. Okay, so those type of motors are not that much user friendly, though, since because of its application. But these whatever mentioned here, these four motors are highly used. Okay, so coming to next. Okay, so let's talk about how we are going to interface the DC, like DC motor. It's a Arduino or general microcontroller or microprocessor. Okay, so basically said, a DC motor, a direct current motor, is most commonly used type of motors due to its simplicity and low power consumption compared to your stepper motors or servo motors. Okay, and a DC motor nominally have two terminals. Like it's not a directional, it's not polarity, like it doesn't have any polarity, so you can just swap the connections across the terminals to change the direction of the motor. So likewise. Okay, and these as we said earlier, so these motors, like generally motors are power hungry devices, like which consumes more and more power in order to perform an action. So it's always advised to not directly connect your motors to your with your microcontroller microprocessor, because your microcontroller microprocessor usually operate in operate in low power when compared to your motor. So your microcontroller or microprocessor won't be able to achieve or provide that enough sufficient power that is required to your motor. So it's always advised to use a bridge called as motor drivers. Okay, so motor drivers, like these are specially designed ICs, or you can say, yeah, ICs, or you can say a circuit that helps in driving the motors. That's the basic function of the drivers. Okay, so if you see in this image, there is a GIF animations going on. So here your motor is connected to the, what you can say, it's a uh, motor driver. Okay, so connected to a motor driver, and if you see at the input terminal, that is A terminal and B terminal, you are just providing like a pulse, basic, like high low digital pulse. So based on the pulse that you're providing, your motor starts rotating, or starts rotate deep. And it also, like, you can also change the direction of the motor, like whether it will rotate in forward or backward depending upon your AV terminal, like how you're providing the inputs. Okay, so yeah, it's always advised to use a motor driver circuit with your mic controller or a processor in order to control your motors. Okay, so yeah, coming to next. So how we going to interface your motor with Arduino? So as we said earlier, we will be using a motor driver circuit. Okay, so this, if you see in this image, here the Arduino is connected to a motor driver called L293D, which is connected to a DC motor. Okay, so this L293D motor driver is the commonly used and widely used motor drivers for your normal DC motors. Okay, so which are capable of providing up to 1.5 amps of current for your DC motors, and it also has separate isolation which can isolate your Arduino from interfering with your DC motor. Okay, and this motor driver also comes with two different supplies. Okay, namely VCC1 and VCC2. Okay. So why there is a two different supply? It's because your microcontroller should first microcontroller should talk with your L293D motor driver in order to whether your motor should be running in forward direction or in backward direction, like that. So in order to have that communication, you need to power up the motor driver controller circuit. So those control circuits will be powered by a supply named as VCC1. Okay, and the one more supply, that is 12 volt, which is given to L293D, will be actually supplying for your DC motor. Since your DC motor is a power hungry device which usually consumes more power, so it will be provided by separate supply called as VCC2. So this is how the interface or this is how this motor driver is connected. Okay, and this motor driver has a pretty few GPIOs, like a direct GPIOs, where you can directly connect those GPIOs with your Arduino. For an example, if you see here, they are connected a enable pin, like EN is nothing but an enable pin, which helps in helps in enabling the motor. Like if the enable pin is zero, your motor, like whatever the signals that you feed to your motor driver, it won't care, like it won't do anything, because the enable pin is low. So as far as the enable pin is high, it won't do anything. Okay, and if you see here, there is two separate pins called 1A 2A. So what is this pins actually? So these pins helps in controlling your motor and its direction also. So if you don't know how, check in this second image. Okay, so if you see here, this architecture, whatever the architecture they are shown, which represents the L293D motor driver. So basically, this L293D motor driver is also called as H bridge due to what is it? Due to the arrangement, of the internal components, which forms a H kind of a kind of a circuit. Okay, so if you see here, your load is connected to a circuit which has 4 switches. Okay, so basically these 4 switches will help in what do you say, control your direction of the motor. Likewise, if you see in the second circuit, they are connected 2 switches by opening 2 switches. Okay, so that's how, if you are doing like this, then the power, like the current flowing from the VCC starts flowed through the switch 1, if you consider this as switch 1 to the load, and switch 4. Okay, if you want to change the direction, just you need to swap the connectivity, like opening the switch 1 and switch 4 and closing the switch 2 and switch 3, if you see here. So that's why that's how your direction of the motor is changed. So this is very simple, like the operating the H bridge operation is very simple. So that's why it's widely used and it's very cheap, if you consider with all other drivers that are used to control your servos and stepper motors. Okay, so in this last part of the circuit, part of the image, you can see how the H bridge exactly actually look like. If you see here, they used 4 MOSFET switches. I think it should be a NMOS, if I'm not wrong. So these are 4 NMOS switches are placed, and these the base of the NMOS switches are taken out as a control signal. Like, and where is if you see the A side, there are 2 MOSFETs, Q1 and Q2, whose base is taken out as control pins of A and 1A and 2A. Likewise, if you want B side, you can take the pins as 2A, 2B. Okay, so this is how you're going to interface your motor with your motor driver. So any doubts, like anyone has any clarification or any doubts? Yeah, similarly, like yesterday, you can just drop it in chat so that we can have a quick discussion. Otherwise, we can continue with our slides. Okay, so yeah. Okay, so the next part. Okay, okay. Someone asked like, what is going? Okay, so GPIO. Okay, so GPIO, like this is a abbreviated term for general purpose input output. Okay, so basically, if you remember in yesterday's session, we were discussing about the major difference between a microprocessor and a microcontroller, where you might have seen there was a separate block called as the GPIO block, which is basically helps the user to interface with the processor or a controller using this GPIO. Okay, so if you consider Arduino, so Arduino has up to 20 or 20 somewhere around 20 to 25 GPIOs that are available, which can be used by the user to interface devices with the Arduino and help. And you can also um, toggle the GPIOs in order to have some uh, in order to what do you say in order to perform your work. Okay. Okay. So yeah, that's actually a valid question. Like, why the motor driver can't be integrated into microcontroller itself? Yeah. So if you consider, like if you see in this picture, I have shown you a L293D motor driver. Right? So this motor driver is capable of driving 2 motors. Okay, so in this image, as they are shown only one motor. So basically, it is capable of driving 2 motors. Okay, so uh, okay, so one is it is capable of driving only 2 motors, and one more major concern is it can't uh, it can't supply more than 1.5 amps. Likewise, if one of your motor is consuming around 1 amp, and and another motor have only a what is that, has only limitation of 500 milliamps, so you can't boost it due to its internal circuitry's limitations. Your current consumption, you can't increase it. And one more major problem is, since these are all power devices, like always there will be a flow of current in terms of amps, the power dissipation will be more in terms of heat, so which ultimately increases your which ultimately raises the temperature of the surroundings. Okay, so if you integrating this motor driver within the microcontroller, then overall all the rest all parts in the microcontroller also heats up because of the heat generated by this motor driver itself. Okay, so you might have seen in the industrial based motor driver circuitry, there will be a huge heat sinks pasted on the motor driver in order to extract the heat that is generated by the drivers. Okay, so that's the major reason why they are not integrating the motor driver circuit within the microcontroller. Okay, but if you see in the recent devices, like in the recent released devices, uh, some are one or two devices have motor driver, but there what is the major problem is you will be limited with respect to the power. Like they will be clearly specified what is the maximum current that you can provide, that the driver can withstand for a particular driving application. So that is the one major drawback. And also it also increases the microcontroller size. Like overall chip size is also affected due to the integration of this microdriver into the controller circuit. Okay, so uh, that's why they won't integrate this. They will have always side part, like external integration. Okay, and okay, so power requirements. So actually this is the major one of the key parameters that we need to consider. So this your power requirements always directly depends upon what is the type of applications that you are using this motor for. For an example, if you want to use this motor for no for a, just to rotate a small fan, a normal fan or a toy fan like that. So you don't require a much current. So it may consume around a few milliamps, like 50 milliamps to 100 milliamps like that. Whereas if you are going with a loaded application, like where you have a lifting machine, where you're using this motor, you need to lift a particular object which has certain mass like that. So there you have to, for those type of applications, you need to first figure out what is the torque that you require. So right, so torque is directly proportional to the current. Like more the current you provide, the more the torque the motor can deliver. So there and all, your power requirements goes on varies. Okay, so it's always advised, or it is always better to decide what is the end application that you are planning with this motor and motor driver filter. Okay, so as I said, based on your application and based on your power requirements, the type of motor drivers also varies, because each motor drivers will have its own limitation with respect to the power delivery. Okay, so uh, if you want to design a project where you want to uh, use a industrial grade motor, or where you need to design a wheelchair where it should pull, or it should push the what is it, object of weight more than 50 kgs like that. So for those type of applications, you won't go with this L293D motor driver. So for that for that first you will calculate the torque that you require, and based on the torque you will start searching for the motor, like the type of motors that supports the torque. And if you select the motor, again there is a power requirement that is given to the motor. Like they will suggest you a single phase normal DC power, or three phase power, or some AC power like that. So it's like a back calculation. So it always you have to first think about the end application that you are going to plan, that you are going to use do using this motors. Okay, so that's about that. And one more. Okay, so each time the motor is controlled by four switches. Uh, Basically, yes, whatever you said is right because since if you see here in this architecture or in this electrical diagram, so one one of the advantage of this L293D motor driver is you can control the direction of the motor. Okay, so if you don't want the direction control, like if you always want your motor to rotate in only in one direction, then you don't require four switches. You just require any of the switches, either of like odd diagonal switches Q1, Q4, or Q2, Q3. So since you have a direction control, so there will be two more additional features will be added. Okay, and coming to this enable pins. So these enable pins, if you see in most of the hobbyist projects or most of the projects, this enable pins is always will already will be enabled. Like they will directly connect this enable pin to 5 volts. So the motor driver will be always enabled and it always ready to accept the data, accept the signals that is provided by the microcontroller. Okay. So yeah, the hard part is you require more GPIOs to control a single motor. But if you go with a higher end and like a new technology based motor drivers, your number of GPIOs is also reduced. It will have a internal subcontroller which will communicate with your Arduino through some of your communications like UART or I2C or SPI based on communication. So there you will be limited. You will be cut down. You are cut down in your number of GPIOs with a normal interfacing line. Okay. So it also depends upon the type of drivers that you are going to choose. Okay. So more like the okay. So someone has asked more like the microcontroller is needed for a broader use case. Yeah. Whatever you're telling is right. Yeah, sir. Because they always they won't be sticking with their particular application because this general purpose microcontroller and general purpose motor driver. So these can be used for a number of applications, but the thing is they have their own limitations. So you need to so your use case should be within the boundary within your processor control capabilities. So if that matches, then you can do a number of applications from this. Okay. So yeah. uh, so moving to your display devices. Okay. So if your motor if your motors are one type of output device, your display is also a type of output device. But the difference is in display device it is electrically, and in motors it is mechanical. So that's the major difference. And you can also have some of the advantage of having a display device in your project because it helps the user to easily debug the issues by displaying what is the status of the controller, and what is the state of any other IO device that are connected to that controller, like that. So these display devices are highly helpful. Okay. And if you see, there are several type of displays are available. Okay. So the traditional or older technology one, it's the LCD display. Oh, sorry, LCD display, which is shown here. These type of displays are like a basic displays, and these are very cheap. And these displays like operating with these displays, like interfacing these displays with your Arduino or any other microcontroller, it's just a straightforward. Like there won't be that much difficult, and everything will be a straightforward, so that it will help the user to easily integrate the LCD display. Okay. And but the major drawback of these displays are very much limited with respect to the row and pixel count. And these displays won't be having any color differences. Okay, so these displays will come in only black. Like if you see here, the green light is just to uh, what do you say, just to make a feel of having a display like that, a display kind of thing. And your the pixels like 2 cross 6 16 LCD I2C. So these are the actual characters that are displayed from the display. Okay. So here the major setback is it's the old style, old fashioned, and there is no change in the color. Like you can't change the colors, and you can't have more what do you say, more complicated, more complex characters and all. So that's all very much limited. Whereas in other side, if you see at the right side, so there is a type of display. So these type of displays are called as OLED display, like organic light emitting diode based displays. So these displays are like newer technology where you can do anything you want. Like pixels will be very smaller, and each pixels can be easily controlled by their display interfaces. So as you can see here in this GIF, you are seeing a three-dimensional cube, and you can also have animations. Like if you want any animations in your display and that you to pop out during the operation, you can have the animations also. So these things and all, like these animations and structures are all what do you say, or modified by modifying the default libraries that are used. Okay. And and if you see both the displays, okay, so there are only few wires that are connected. One is the VCC, that is power supply, and one is ground, and there's two signals called as SCL and SPA. Okay, so these SCL and SPA belongs to a type of interface called as I2C, Intel Integrated Circuit. But I don't know, like whether you people are come across this I2C interface, but anyway, in any you will be you will be reading about these interfaces in your upcoming semesters, like when you get a chance on uh, going with the microcontroller, microprocessor systems. Like that. So there you will be getting these interfaces. Okay, so these are the what do you say? These are the type of interfaces that are used in modern day interfacing, modern day uh, sensors interfacing, which drastically eliminates the number of wires that is required, and it also has certain advantages. But for now, I think you don't require. It's okay to not to concentrate more on this I2C. Okay, so this is about the display, and yeah, coming to the type of displays that are compatible with Arduino. Oh, as I said in the previous slide, so each displays work or each displays are interfaced with your microcontroller microprocessor based on the libraries, with the help of the library. Basically, this library will act as a connecting bridge between your LCD display and the microcontroller. Okay, so not all the what do you say, all the displays or all the LCD displays are compatible with your Arduino because of its complexity, and also due to um, due to the library structure. Okay, so as Arduino is an open source, so more open source projects are carried out, and more like open source contributors are keep on developing the different type of interfaces that can be used to interface the devices with the Arduino. So so now, as for now, there are six different type of displays that are compatible. Okay, so one is the TFT LCD display. So TFT LCD displays are the type of displays that were used in on older days, in earlier days, LCD, sorry, touchscreen mobiles. Okay, so basically this one is a thin film transistor based LCD display, so which has a touch capability. Like you can use this display as for your what do you say, for touch-based interface projects. Okay. The next one is dot matrix display. So dot matrix display is also a old-fashioned type of display where the characters are formed by illuminating each individual LEDs that are represent in the form of dots. Okay. And next one is a OLED display. So this one is like a modern type of display uh, which can be easily connected with your microcontroller or microprocessor just by accessing one of its communication interface called namely I2C or SPI or UART like of interface. Okay, and the next one is the LCD. Yeah, again this one is old tradition display. Okay, so uh, the next one is 5110 graphical LCD. This is again what is it? The improved version of normal LCD, which has more accessing features when compared to this normal LCD. Okay, and the last one is the second seven segment display. So seven segment display is also a old fashioned display which are highly used to represent numbers. Okay, so you can't so there won't be any other representation. Just to represent a numbers, you will be using the seven segment display. And I think most of you already should come across this seven segment display, because these are easily to like these displays are easily to access, and the level of complexity is very less when no, compared to your TFT LCD display. Okay, so yeah, these are the different Arduino compatible displays that we can use in our daily life projects. Okay, so any doubts or any questions? Um, Anyone? Okay, so yeah, uh, I think with this we are the completing with the what is it theoretical parts. Okay, so now we'll be jumping into hands-on. Okay, so as discussed yesterday, like for hands-on we'll be using one minute. For hands-on we'll be using an online tool called as Tinkercad. I think our organizers will be has already informed you to just create a login in the Tinkercad website, right? So um, so if everyone is having a Tinkercad, I think uh, I suggest you to just open the Tinkercad so that we can start what is it? We can start coding our boards. If anyone has any issue with regarding opening the Tinkercad, just drop it in the chat so that we can try to rectify it here itself. And also let me know once you opened your Tinkercad, okay, so that we can start with coding.
Guys, if nobody has any issue opening Tinkercad and logging in, then maybe we can proceed. Drop yes in the chat if nobody has any issue.
Okay, so I think most of them were able to open the tool without any issues. Okay, so so I think we can start it. So once you open your Tinkercad, so you won't be having any like it won't it will be a complete a blank page. Since I have already created some of the circuits, so so there is some blocks, some like components on my drawing board. Okay, so when you are going to start your what do you say, your simulation or connect circuit connections. Okay, so at the right panel, so you'll be having a display or like a drop down where you can choose the component that you want to use in your circuit. Okay, so here I think you can pick any component any of the components. Okay, like an example, I will pick up Arduino. Okay, so if you click on that Arduino icon, so wait a second. Okay, so yeah, okay, and for an example, we can what we can do is we can have some basic analog input and digital input interface, and analog output and digital output interface. Okay, so for analog input, what we can use, we can say we can use something called, okay, so it's not visible here. Okay, so we can use a potentiometer. So potentiometer is one of the best example for your analog input. So where you vary the vary the resistance, which will be captured and can be recorded from the controller. Okay, so once after you dragging it to the drawing board, so if you hover your mouse on the pins, okay, it will show you, it will show the name of the pin. Okay. For a zoom, I think you can just use your scroll button on your mouse to scroll, like zoom in or zoom out. Okay, so here there is a name called terminal 1, and there's a name called wiper, and there's a one more name called as terminal 2. Since the potentiometer is not a polarity based, okay, it's a polarity less, like you can control it any way you can want. Okay, so here if you see, the terminal 1 and the terminal 2 is just like a power supply. Okay, like where you need to feed the power. Like an example, in terminal 1 you can provide VCC, and terminal 2 you can just connect it to ground. And the wiper pin is the one which records the value, which records the resistance value that you're changing in the potentiometer. Okay, so this wiper pin will be taken as a input, because uh, you want to record or you want to read the analog value, right? So for creating the circuit, what you need to do is just hover on the mouse on terminal 1 and do a click. Okay, so it will start to trace, and there are some uh, helping hands, like horizontal lines and vertical lines, that will be provided by the tool in order to ensure a straight line. Means in order to have a straight line in the circuit. Okay, so this terminal 1 I will be connecting to 5 volt. Okay, and the wiper. Okay, sorry for the lag, guys. Since it is an online tool, it consumes data, and it's pretty much slow. If you have better connectivity, I think you won't be experiencing this lag in your device. Okay, and coming to the wiper pin. So wiper pin, I'll be connecting to one of my analog input pins. Okay, so yeah, we can connect it to A0, and the third pin, terminal 2, I will connect it into ground. Yeah. Okay. Yeah. So I connected the ground. Okay. So now, for now, I think our circuit is complete. If you look, everything is connected. So one more important thing is how you are going to change the values of these passives, like resistors or capacitors or potentiometers or batteries, like. So that can be done just by clicking on the potentiometer. Okay, if you click on the potentiometer, you will there is some pop-up will be enabled, which will have its name and the value. Likewise, in this potentiometer has a value of 250 kilo ohm. Okay, so I will just change the value to uh, a 10k. Okay, so it's just it's completely user independent. Like if you feel if you want a higher capacity, higher resistance, you can have it. Okay, it's just a matter of the current that will flow into the circuit matters. That's all. Like if you have a 1k potentiometer, it will consume more it consumes more current when compared to your 10k potentiometer. So that's all the matters. Apart from that, everything is fine, everything is the same. Okay, so I changed my potentiometer what do you say, potentiometer resistance or resistor value to 10 kilo. Okay, so now if you see, the circuit is done. Okay, so the next part is how you're going to program, like how you're going to inform your microcontroller to read the analog value that is coming from the potentiometer. Okay, so for that, if you hover your screen, hover your mouse on the right top corners. Okay, so there are few tabs called code, start simulation, export, and share. Okay, so basically the code tab is used to help the people to code. Like if you like you need to code the program, if you need to code your Arduino or any microcontroller, so you can just open the code terminal and you can start coding it. Okay, so once you done with your code, you can start simulating, like pressing the simulation button, your circuit will start getting simulated. Okay, and this export and share is like a general tab that you see in normal website, like exporting your project and sharing your project. That's all. Okay, so one of the interesting point of this Tinkercad is they introduced the block level coding. Okay, so basically this block level coding is used when you are used by the people who are very new, like they are completely new to the coding, and uh, one is they are completely new to the coding and they require more time to gain the coding knowledge. Basically, like this block level coding or what you say, are highly used by the children. Like I say, since children will be studying in the school, so they won't be having any coding knowledge or any other coding basics or syntax like that. So for those kids, this block level programming is very appreciated. Okay, so this block level programming is just like a drag and drop mechanism where you can pull it, push it like that. So whatever you want, like if you want to configure output, so you have these uh, type a number of outputs that are already predefined. So if you're planning for input, so this one has separate set of programming blocks. So similar way, if you want to control, so they are separated. Okay, but for you people, it's always better to go with our traditional coding method. Okay, so for that, if you want to switch to traditional way, just click on this drop menu. So it will have blocks plus text and text. Okay, so we are going with text. So click on the text. It will check, it will ask you for, are you sure want to close the block editor. So anyway, we are going with the text, so we'll click on it. Okay, so if you click on the text, it will your text terminal will be opened. Okay, so this text terminal is almost similar with the Arduino coding terminal. Okay, so here you need to write the code, and if you start simulating, it will build, compile it, and it will start simulating. Okay, so okay, so till now, anyone has any doubt or any anyone had any difficulty in connecting the circuits or finding the components like that? If anyone has, just they can drop it in the chat so that we can discuss. Okay, so I think most of them are able to mm, do it without any issue. So yeah, so coming to the coding part, since this Tinkercad already has its own coding terminal to code your controllers or programmers, I will advise you to have a separate terminal uh, from the Arduino. Okay. 1 minute. Okay. So someone has asked something. The wires are not bending, so can you reconnect it going forward? Okay. Yeah. Sure. Uh, okay. So just I will remove one of the connectivity. You just click on it, delete. Okay. So you just wait a minute. It will take some time to delete. Okay, sorry guys. So this lagging wall is because of poor connectivity. Okay, I will just click on it and just delete it. Okay. Yeah, it's deleted. Okay, so you want to clarify how I done this bending, right? Okay, so just click on the terminal. Okay, have vertical alignment and just drag the mouse. Okay, so okay, sorry. Just have vertical alignment. Left click. Okay, it will lock the lock that wire. Okay, and again you can move it to left or right depending on whichever side you want to do. Extend it till the particular pin that you want to connect. Okay, and again click, it will lock, and again the direction. Okay, and click. Okay, so that's all. So okay, how to delete a particular section, right? Just click on the wire. Okay, it will it will be highlighted you with some light blue, like those shades with some markers. Okay, so these markers are used to need to align are used to align your wire. If you click on the marker and if you hover the mouse to left or right, it will move. Okay, so I will just make it straight. So I will wait for the vertical line. If I am getting vertical line, yeah, done. Lock. So that one will have a proper in order to have a proper connectivity diagram. So these what do you say? These points are used. Okay, just click on it. It will just go off. Okay, how can you increase the size of the coding? Okay, so for now, even I have gone to those things. Okay, I will let you know only the master zooming is available. So I don't think the terminal has any separate zooming option. But I will explain like what all things are there. Okay, so for now, wait. For now, I will just erase everything, whatever the terminal has. Okay, so minute. How to select initial circuitry before Arduino? Okay, so initial circuit. 1 minute. So as you can see here, before the session, like before the starting of the session, I already had some simulations going on. Okay, like I had some backup simulations running out. So that's why my drawing board had a circuit. Okay, so if you are new, like if you are starting a new project in the Tinkercad, you won't be having any simulations or any circuit showing up. You need to just go on this, click on this, what is a circuit view, to expose the component so that you can start rigging it up. Okay. Okay, so top right below profile, click on code. Next, click on block, change it to text. Yeah, whatever you are telling it right. Yeah, if I click on the code, the code terminal will open. So it is in the text. Okay, so if someone wants block, you can just click on the block. It will just uh, ask you for a double confirmation, because sometimes you'll be already created a 200 300 lines of code. So if you're directly switching it to a block, then your all the codes will be get erased. So that's why there will be double confirmation from the Tinkercad tool. So if you want, you can switch or not. Okay, so actually the wiper, the what is the there is no specific what do you say? There is no specific function that is defined to the wiper. Okay, so if you want, okay, I will show the potentiometer. Okay, potentiometer. If you just search what is the potentiometer is, you'll get pretty decent examples, are pretty much detailed circuitry. Okay, so yeah, basically, oh, wait for a minute. Okay, so if you see here, so this is the potentiometer. Okay, so basically, as I said earlier, the potentiometer is not a polarity based component. It's just an unpolarized. Like you can connect whatever the, like you can connect however you want. Okay, so potentiometer, all the potentiometer, traditional potentiometers will have 3 points, so they can be used as VCC, ground, and output. Okay, so whatever the pin wiper that we saw in the Tinkercad tool is nothing but an output. Okay, so the name of the output they named as a wiper. So apart from that, there is no much specific or specific reason or specific application associated with it. Okay, so as you can see here, so based on this pinout. Okay, so we have connected our potentiometer. So one of the pin is connected to 5 VCC, one of the pin is connected to ground, and the middle pin, basically an output or a wiper, that is connected to our intended GPIO. Okay, sorry, an analog input. Okay, okay. I think someone has given some hint. Okay, you can increase the size of the coding font. Wait, I will just have some permission. Font just by control plus shift plus, okay, control shift, um okay, so I think there will change control, yeah, that can, okay, so the control shift plus key method is not working. Yeah, the one more thing is, yeah, you can just zoom the entire page itself, like, okay. So as I was telling earlier, whatever, like you have a terminal, like you have already a coding terminal in the Tinkercad, but I advise you to always have a uh, separate coding terminal that is specified by the microcontroller or microprocessor. Okay, for an example, if you are using a Arduino, like Arduino microcontroller, so it is always advised to have a coding terminal which is which is made for Arduino. Okay, so for this, I'll show, there is an online editor tool from the Arduino called as Arduino Editor. Okay, so this one you can try. Like this is an online editor where you can edit the codes for your microcontroller. And one of the advantage of using this one is here, the Arduino editor automatically enables or highlights the keywords that are associated with the Arduino library. Okay, so if you are using any new libraries, you will get to know whether it is associated with Arduino or it is a new library that is not yet associated with Arduino. Like it is a more user friendly kind of a thing. Okay, so this one, I think I'll just put it in the chat. Okay, so that everyone can access it. So this Arduino editor, Arduino online editor requires a sign in. Okay, so I just signed in with my profile. So you can just sign in with your Google accounts also. So the sign in won't be taking that much long time. Okay, so it's better to open the Arduino editor, like Arduino online editor. So if you're having any issues, just drop it in the chat so that I can clarify it. Okay, if you are if you can able to open the Arduino editor, just leave just drop S, or yeah, can drop the S so that I can continue with the coding. Okay. One more thing, guys. Actually, I have given the link from my, like, what is it, from my login. Okay, so if you're trying to opening the link, you will be uh, pushed out from the editor, and it will ask for a sign in. Okay, so I think I can show it here. Okay, so just if you are not able to open it, so you can just directly go to arduino.cc. Okay, so if you type arduino.cc, it will uh, 1 minute. I mean, okay, so if you are opening, like if you open the arduino.cc, so the main Arduino page will be opened. Okay, so here go with the, what is it, go with the cloud. Okay, so a separate page will start popping up. Okay, so once you open the, like once you click on the, what do you say, cloud, a separate page will be opening. Okay, so here it will be it will show what are the, like, advantage of using a cloud based applications, or blah blah. So many things are there. So here just click, there will be three different icons will be showing. One is IoT cloud, and one more is web editor, and one more is manager for Linux. Okay, just click on web editor. So if you click on the web editor, it will just take some time to, like, it will ask you for you to have a login, and if everything is proper, then it will just open the, yeah, it opened. Like, this is your starting page, it will be there. Okay, okay, so actually the program that is showing here is already, like, I have already programmed it. Okay, so for you people, it will be just opening as a blank page, like whatever the pay, or like what we saw here. Like, there was something like predefined codes was there, no? So you will be seeing those things. Okay, so just don't worry on that. Okay, so someone asked, the code is in which language, like C or Python? Okay, so yesterday, like I was mentioning you that the Arduino program is complete a mixture of C and C++. So basically, so there will be some parts will be in, or some parts will be coded in C, like the background is coded in C, and some part is coded in C++, and they also use Java to make it more user friendly, like that. Okay, so once you open the Arduino text editor, okay, so there are few, what do you say? There are few tabs, and there's something. So once you're able to open the editor, just let me know. Like, we can start with the further things. Or if anyone facing any issues, just let me know that I can just walk it through from my side. Work it from my side. Yeah, as you said, there will be a dummy program which has only that, like whatever you're seeing here. So it will be like this. There will be a void setup and void loop, just nothing else. It's this is the normal way how your editor will be open. Okay, so if you're getting this, then it's fine. Yeah, you will be proper. So if anyone faced any doubts, or we can or can we proceed with the. Okay, I think everyone are able to open the editor. Okay, so once after you're opening your editor, okay, so there is a dummy, there is a dummy syntax is showing on. Okay, just click on Control A and delete everything. Just make it a blank. Okay, so that you can easily access. So coming to the coding, since you are coding a microcontroller, okay, so you should be clear with what are the pins that you're going to use, and what are the input pins that you're going to use, and what are the output pins that you're going to use. Okay, so once you're fixed with these things, then you can easily start coding in your text editor. Okay, so in our case, we are using a pin called A0. Okay, so analog pin, like we are using an analog pin called as A0. So we should keep this A0, we should keep this in mind, and we'll once we start the program, we'll enter here. Okay, so in the yesterday's sessions, we were going across the syntax, like the basic syntax of Arduino. So in order to have a analog, like in order to read the analog sensor values, so we need to have. So wait a second. Have something called as the analog input. So we'll hover onto analog input. So if you see here, so the basic keyword, the basic keyword for the analog input is analog read, like with braces, which defines you which pin you are going to read. Okay. So the same thing I am doing here. Like first I will assign the input with an variable. I will take the variable as int. So you people might have known, like there are types of variable data types like int, float, long, double, like that. So you can just use a int, because this whatever you're storing the data is just doesn't have that much of weightage. So it's just a normal random value. So you can just store it in int. But if you want a precise if you want a precise value to be captured, then you can go with float. It will just add a decimal, correct? So yeah, I will just get back to the Tinkercad. Why I am diverting it from the Tinkercad is because for coding, for coding the Arduino, it's better to code it in the Arduino editor, because here you will get to know what is the exact error that you are getting and how to debug it. Okay. Sorry, yes, I did 2 minutes. So yeah, this is okay. I think this one is yeah, this zooming is enough. I think. Okay, so first what we do is we'll just define the variable for our input signal. Okay, so what I will have is I will name it as a pot underscore sense. Okay, so this one is for my input. My input is A0. Okay, so I am terminating. So this is the basic pin assignments, like how you want to proceed with the pin assigning or variable declaration and those things. Okay, so I have assigned I have taken a variable called as port sense for my input, and one more variable to store the values. Okay, for this I will have naming called as pot val. Okay, so that's all. So these are my basic variables that I am going to use in this circuit. Okay, next our default, that is void setup. So as we discussed yesterday, like void setup is the one where you okay, the part sense is nothing but the name that is given to your input pin. Okay, so if you see here, the input is A naught. Okay, so you are naming the A naught to a particular name called as part sense. If you don't if you don't want it, then you can just remove it or comment it, where you can directly use the A naught in the code itself. Okay, so if you don't want that, if you just want to provide a separate name for it, you can just provide a variable name like a pot sign, or some like pot, or something your wish. Okay, but don't forget to assign the pin numbers for it. So coming to the void setup, so yesterday like we discussed that void setup is the syntax where you'll what do you say, where you'll code, where the things will be run, where the things are executed only once, only once, or at the starting point of your microcontroller. Like whenever you power down, so this void setup is the one which will be executing first, and it will execute only one time. So once it is done, it will just jump to next next what do you say, next part called as void loop. Okay, so here what I am going to do is for now there is nothing to define, since you don't have any GPIO pins that you are going to use as output. Okay, so one thing you people need to have it in mind is so whatever the unlock signals, like unlock pins that you are using here, like A0 to A5. Okay, so these pins are like these pins are dedicated for unlock function. Okay, so you don't want to mention it, like you don't want to mention it here in a way like pin mode comma A0 comma input. Okay, so this one you don't require it actually. So if you are changing the unlock signal, like if you don't want to measure it in A0, you want to somewhere like pin number 2 or pin number 5 or pin number 7, like that, there you need to mention this statement at the beginning of your void setup, because these uh, these pins, whatever the pins, the numbering from 0 to 13, like these are the GPIO pins which has a which are defaultly considered as a digital pin, and you can also convert the digital pin into analog pin by naming it to here like this. Okay, so as we are going with the dedicated analog pins, then we don't require this. So for now I'll just make it a comment. Okay, okay, so one more thing, sorry for the background noise, because here it is rain heavy, so I think you might get some disturbance. Okay, so just follow with me in the code. Okay, so that if you have any doubts, then you can clarify it right there itself. Okay, so next we'll go with void loop. So this is the part which will be keep on executing endless time until and unless you are putting your controller to sleep, or switching off the power, till the time the statements or the program that saved inside this void loop will be executed. Okay, so here what you want to do, you want to sense the signal. For that, what is the keyword that we saw? We saw like analog read. So this is the keyword that is used to read the analog data at a particular signal. Okay, so this one, what we can do is we can have analog read of pot sense. Okay, so this is what, if you write this, if you execute this command, it will start reading the value, or it will start reading the analog value that is present at the pin A0. Okay, so so during the input, someone has like pot sense is a variable name, correct? So if you don't want a variable name for your input, you just directly you are planning for a direct reading of the signal. So at that time, what you can do is you can just type analog read, and you can directly mention the particular pin that you want to read. Okay, so either of the case will work. Okay, so if you are very much familiar with the pin number, you can directly drop the number. Otherwise if you don't like, if you don't want to mess up with your numbers, then you can create a local create a variable name, and you can assign that name, and you can use that name wherever you want. Okay, so for now we'll stick with our the first plan. So now what I'm doing is I'm just reading the send signal. Okay, but I need to store it somewhere in the register, so that I can able to access it whenever I want. So for that we need to have on a register, correct? So initial at the start of the code, we taken one more variable called as pot val. Okay, so this pot val is the one which will be storing all your analog, like all your potentiometer readings. Okay, so what we can do is we can just initiate pot. Okay, wait, I can just type it here itself, like pot underscore val value equals analog read of pot. Okay, so this is what here what the controller will do is it will just read the uh, it will just read the potentiometer value, and it will store it in the potentiometer pot val register. Okay, yeah, someone has said like analog read, for analog read no need to tell high or low, correct? So since you're reading the analog input, so analog is just an analog, what is it, it will be variation, there will be variation in the amplitude level. So you are not going to what you say, you are not going to tell the controller or processor whether the input will be high or low. So it's completely uniform, like completely, what do you say, completely unique. Whatever the values that is presenting that working at the pin, it will just read. Okay, so you don't want to mention any, like you don't want to predefine any values. Okay, yeah, only in the digital we use that value, since the digital inputs will have only two logic levels, that is logic 0 or logic 1. So we will be predefining with any one of the logic, so that we can, like, basically we will be compare whether the whatever the logic that is getting at the input pin is equal to whatever the logic that I am expecting. Okay, so basically a comparison. Okay, so for now, since it is analog, so I am reading it, so I am storing it a value. Yeah, basically when you start, like whenever the controller starts executing this particular piece of command, it will start to read the data, read the value of the particular pin, that is A0. If you see in the circuit, so the A0, the pin A0 is there, right? So the controller will start reading the signal, whatever the signal that presents at the A0. So whether your what do you say, whether your sensor is active or inactive, it doesn't like those things and all, your microcontroller won't care. So it will just start to record the value that is presenting at that pin. Okay, so instead, if you remove the connectivity, and if you provide any other signals also, it will accept. So it will just, like, whatever you define it will just keep on looking on this. Okay, so now I have done it. Okay, okay, so why I am not using a pin mode, correct? So because if you see the Arduino board, okay, so the GPIOs and the IOs are splitted into different format, namely a digital one and analog one. Okay, so the digital inputs and outputs are used for digital based communication, where you have digital sensors or digital output devices, and you need to communicate it with logic levels, like 0 or 1, like that. Okay, so there is one more section called as analog in. So here you will be using this analog ins to read the value from the sensors that are analog in nature. So that's why they are there. That's why they are also they predefine it as analog in, means analog input. So since this is already analog input, so you don't need to define it exclusively in the code, because the Arduino, like the Arduino firmware or a bootloader that is already present in the controller, it will take care of it. Like whenever you are setting, whenever you need to read something on the pin A note, it will directly take it as an input and it will start reading. Okay, but if you don't want these pins to be analog and you want to change the behavior and you need to make it as digital output, at the time you can modify that same a naught as output by by using the pin mode command. Okay, so that is the major that is the reason why we are not using any pin mode function, pin mode keyword for our analog input signal. That too, if you are connecting that analog signals or analog sensor data to this analog input pins. Okay, so I think you are clear that. Okay, so moving on. Yeah. So okay. So for now, whatever we are done is just okay. So once again, so for analog, no need to use pin mode, only for digital. Yes, absolutely. So if you're connecting, yeah, like if you're connecting your analog sensors, if you're connecting analog sensors to this analog pin, like and this A0 to A5, so you don't need to specify it in your code. The code, the what do you say, the hard, the default bootloader will take care of it. Whether your pin, whether your sensors is connected in analog sections or a digital section. So if you're connecting it within this A0 to A5, you don't really require to specify it in your void setup. Okay. So moving on here, now we are just what we are doing, we are just collecting the like we are reading and we are storing it. Okay, but you want to see what is the value, right? So you want some IO system, like output device. So for this, there are multiple ways you can express it. Like for an example, you can use you can connect an LED to one of the one of the GPIO pin, and you can specify in the code that once your potentiometer value raises more than 1K, the LED should on. Or you can have something like you can have a buzzer, and uh, you can modify your code so that you once when your potentiometer value is rising to a particular level, you can, the buzzer will activate like that. Okay, so these are like external, like you will be you need a external components to be fitted with your control in order to what do you say, in order to showcase. Okay, so uh, there is one more way to get this data from the controller using a software method. Okay, so it's something called as, there is something called a serial monitor. Okay, so yeah, if you see this code terminal, okay, there is a, at the bottom of the code terminal, there is a separate terminal called a serial monitor. Okay, so this serial monitor is a software is basically what do you say, basically a debug monitor, which helps us to get the data from the microcontroller through software, with the help of software. Okay, so basically you people might know that in order to program the Arduino, you need to connect your what do you say, you need to connect your Arduino to your laptop or to a PC system. So once you connect with that, say your what do you say, your Arduino will establish a communication with your laptop or a CPU. Okay, so the serial monitor, once upon opening the serial monitor, the communication, the like whatever the data that is present in the microcontroller will be transferred to through the USB lines to your PC, and PC will process it and it will display it in the serial monitor. So this is basically a software based debug. Okay, so in order to enable the serial monitor feature in your Arduino, so you have to do some, like there are some certain keywords that you need to include in the library. Yes, I include in your main code. Okay, so for that, whatever like we need to have some setup. Okay, since we are opening a serial monitor, like we want a serial monitor, we want to have a data transferred to a serial monitor. So there is some particular keyword called as serial dot begin. Okay, so this is a particular keyword which is used to initiate the serial monitor feature in your controller. Okay, so within the braces, okay, so there will be a particular type of there will be a value mentioned. Okay, something like 9600 or 9600 or 115200 or 912600 something. Okay, so there will be some numbering will be there. Okay, so what this number defines is this number defines the speed of communication. Like say if it is a 9600, this defines the Arduino and the your laptop or system will communicate at the speed of 9600 baud per second. Okay, so it's mentioned as 9600 bps. It's nothing but baud per second. Okay, so this is the standard term that is used to define your speed of the define the communication speed. Okay, so what is baud? Baud is basically a baud is nothing but number of translation. Number of translations. It's basically a number of translations. Okay, so it just defines how many translations are happening, like how many translations are happening in order to push out the data from your controller or the processor to your PC. Okay, so I think if you Google out, you will find a more detailed explanation on baud. Okay, so for now I think this is pretty much enough. Like what is meant by baud is nothing but a number of translations that is happening. Okay, number of translations per second defines your speed of your serial communication. Okay, so this is the starting point. Okay, so once after it, I will have a welcome note in my serial monitor, which will show you whether your controller or processor is active. Yes, yeah, it's much more similar like bits per second. Okay, but the bits per second, but you can't compare it for now. For this Arduino, I think your baud and bit are same. Okay, but in most of the cases, this bit per second and bauds per second will be different. Okay, so there is some high level what do you say, there is some high level uh, conversions that will be happening in the controller. Okay, so your bots is just defines you the translation. Okay, so if you consider a digital logic, for an example, if you consider digital logic, you will be having a logic like 0 or 1, correct? So this is the basic logic level that you know. Okay, but there are few high level logics, okay, which will have -1, 0, or positive. There will be 3 different levels. Okay, for those things, your bit per second won't applicable. It won't be applicable for those things. Okay, at the time, what will you what will you use as a sorry for those things? The baud means the baud will be 3, because in our proper data transmission, you have 3 different translations. That is -1 or 0 or 1. So your baud will be different. Okay. So for your basic basic digital interface that is happening in your Arduino Uno is 0 or 1. So it having 2 bauds, means maximum translation will be either 0 or 1. So there is a complete different what do you say, different domain which deals with these all those encoding schemes or symbol conversion schemes, that these things and all you will be studying in your I think 5th sem or 6th sem syllabus. There will be a separate topic called there is a separate topic, signals and systems, and digital signal processing and all. So there you'll be getting what is in the board and what is how it is different from your BPS. Okay, so okay, so now I defined my transmission, like what should be the speed of my data transmission. Okay, the next I will start to have a welcoming note from my from my microcontroller or microprocessor once it is active. So for that, what I will do is I will just type serial dot print, okay, and the opening brackets. So serial.print is a keyword which will print whatever the data that you whatever the data that you are pushing, like what that you are providing it inside the braces. Okay, so since I am not providing any variables, I'm just providing a constant. So you people be knowing, like for constants you'll use a double colon, correct? Sorry, not double colon. It's what is it? Like inverted comma, like something. Okay, so serial print of, I will just tell like system is on. Okay, I will just type it as system is on, like uh so that whenever my, like whenever I am switching on my Arduino, so I will be getting this message, yeah, in my PC. So whenever the system. Okay, so after that we need to start extracting the analog values, and we need to we need to post it in the CPU or your PC. Okay, for that what we'll do is we'll just again use the same keyword called serial dot print. Okay, braces. Here I am going to uh, print a variable data, like the data won't be constant throughout, so it will be keep on varying. So I will just write it out. Okay, so pot val means I'm just printing out whatever the values that is stored in the register pot val. Since it is not a constant, it is variable, so I am not using that inverted brackets, sorry, inverted commas. Okay, so once after you're doing this, your system will start pushing out the data from your controller to your PC, so that you can able to view it. Okay, so once you are done with this, so this is your basic code. Okay, so if you start running it, it will run. Okay, I'm just for now. So can you please? Yeah, sure. At the end, I will let you know. Okay. So for now, so this is what we can say. This is the the bare minimum code that you require in order to extract the sensor value. Okay. So for this, what I will do is I will add one more thing called a serial print, and I will name it as something called as potentiometer value. Like I will just name it as proper, in a proper manner. Okay. So oh, sorry, man. I think I forgot it completely. Yeah, there is a semicolon required in throughout the codes. Okay, so if you're missing the semicolon, it will pop out. It will throw out an error. Okay, so the semicolon is very much important. Thanks for informing me. Yeah. So so I just added a new line called a serial print of potentiometer value. Means this will what will do is it will just display display potentiometer value with colon. After that, your pot value will be displayed. So it will be something like potentiometer value and some numbers 25, like that. Okay, so this is how it will be displaying. Okay, and there's one more keyword that you need to add is control print underscore just empty. Okay, so the use of this keyword is whenever your what do you say, when your controller keeps on executing the commands. Okay, so once it executes these two commands, it will again start reading the data, and it will start printing the data, correct? So if you don't mention this, like this empty line, it what will do is it will just print data here itself. Like it will be in a sequential manner, so there won't be any proper separation of those things. Okay, so for this, what we'll do is we'll use a something called like what we'll do is we'll just print empty, like we'll just have something like this. Okay, so if you write this command, it will just leave out a space. Okay, before adding that serial print with empty bracket, it will be like this. So once you add this, it will have a break. Like it will create a like a one text space like that. So this is one method of separating your output data. So some people may think like I don't want the sequential manner. I just like I don't want it in horizontal manner. I just want it a column manner. So if you want to do that, like if you want to output your data in those manner, then what you can do is you can just extend the word, like instead of serial print, you can have ln. Okay, so ln is like serial print ln is one of the keyword which is used to create a new, like what you can say, create a new line for the data. Okay, so whenever you use this one, the data will be pushing out in a what is it, in a new line instead of having it in a sequential or horizontal manner. Okay, so yeah, if that is done, then our for now our code is pretty much done. So someone else, can we use percentage %d for points so that we can reduce code line string formatting? Yeah, even those raw C coding language is also accepted in the Arduino text editor. Okay, so if you want, you can use those things. And also the major the major setback of using a predefined library, like predefined Arduino libraries, which includes your serial print or serial begin or pin mode analog read, is these are set of what is it? These are set of functions that will be running background, that will be running in the background, which uses a raw C or C++ coding. Okay, so since to make it easier, since to make it easier to code, so they are constructed in such a way that it will be in, like this. It is this much simple. Okay, so if you are good at your basic what is it, raw level C or C++, I think you can use those things as well, because the editor will understand those things also. Okay, so for now we are just going with the predefined what is a predefined coding format. Okay, so once you are done with this, okay, at the top of your coding script, there is something called a tick mark, which will say you which is used to verify your code and save the code. Okay, so if you click on it, it will just start verifying. It will just check for errors or any other. Okay, so yeah, there's some error coming on, expected serial, expected semicolon. Okay, so the one thing that we missed. Okay, so just modify it and again click on. So once it is done, it will just say the compilation success, and it is already saved, like it's saved online. Okay, so below there is something, there will be some logs that will be running on. Okay, so which will show you what is the memory that your code is consuming, and what is the memory left in your controller, since each controller have its own set of memory levels. Okay, so the Arduino has 32 KB of programmable RAM, programmable flash, where you can store your code or your data or whatever thing. Okay, so this small piece of code consumes around 1818 bytes of your program. That is 5% of the maximum storage, and it also defines. It also pops out how much global variables that you are used in your coding. Okay, so for the small level projects, I don't think you need to really care about this. So when you are having a big project and you have more line of codes that you are running, so those times you need to be careful on how much you are actually using, and uh, how much space is left. Okay, so it is always advisable to use 75% of the 75% of the available resource in your processor or controller. Okay, So if you're going more than that, then your controller processor will start to delay the work, and it will start to hang itself. Okay. So yeah, someone asked what is the use of serial print length. Okay. So if you're having like if you're using the serial print length instead of serial print, so what is the behavior means? I will just show you the expected output that is coming. Okay. So basically it will be like potentiometer. Potentiometer value is equals to 25. Okay. So this is the default, like this is the expected output that will be sending out from the controller. Okay. So if you don't have ln, like if you just have serial.print, then what then the next data, like the next output will be like it will be like this. So the output data won't be having a proper formatting, so it will be like complete in a sequence manner. Okay. So in order to overcome this, what we'll do is we'll add a keyword called serial print ln. Okay. So what these things will do is it will just okay. Yeah, it will it will maintain a proper formatting. Like it will start to plot your output data in a column manner. So where you will be able to easily notify what is the current value that is read by the controller. Okay. So that is the main usage of this serial print ln. Okay. So once you are done, like once you're done with the coding, so what you can do is we need to put it in the Tinkercad. So for this, the simple way, uh, copy the copy the program, okay, and paste it here. Okay, that's all. Just copy it there and paste it here. Okay, so if you paste it, it will automatically take care of it. So since you are using Arduino controller in the Tinkercad, so Tinkercad will have all those basic Arduino files that is required uh, in order to validate and compile the code. Okay, so once you copied and pasted it here, you can just click on Start Simulate. Okay, so press on it. Okay, wait. I will zoom. It will just take some time to initiate, and it will let. Oh, yeah, your simulation is on. Okay, so how to know your simulation is on? So once your what is it? Once it's done and it starts simulating, it will indicate a stop simulation symbol. So if that is coming out, then it means your simulation is on. Okay, and here at the left side you will be seeing something called a simulation time. This is nothing but what is the time that your simulator is taking. Like currently it's around some 18 or 100 milliseconds like that. Okay. So I think now you people might understood like what is the use of having a serial print line. If you see in the serial monitor, okay, 1 minute. Just a minute. Okay, if you see the serial monitor here, the value is printed in a column manner. So that is that's why we are using the serial print line. If you are not using serial print line, if you are directly using the serial print, then whatever the data that is pushing out from the controller will be in horizontal manner. Okay. So now if you see the value is 1023, like there is some value 1023. Okay. So that is the analog value that is right from this analog input. Okay. So what you can do is you can change the potentiometer value just by clicking on the knob. So in the knob there is a particular marking indication. Okay. So you can just hover your mouse to some other points, like just click on it. Yeah, it will just change your knob direction. Okay. So if by changing the knob direction, I think you people might see 1 minute. Yeah, see there is a change in the output. So before during the initial knob direction, it was 1023. So now I moved exactly half of its full scale reflection. So I got 511. So again, if you want to change it, just hover it to some other location and just click. Yeah, it will change. So yeah, this is the basic, like how you want to how you're going to interface analog sensor into. Okay. So yeah, if anyone is trying out, just let me know whether you could able to get the same data, or you are facing any issue. If you are getting as expected, then you can let me know so that we can jump into the digital one. Okay, not able to change the potential. I think it is the potentiometer value, I think. So for that, what you can do is you can just zoom in, and you can hover your mouse to some of the points where, like, there is some points that is like there is some markings that is shown in the potentiometer, no? So you can just click on it. It will change it. Uh, okay, so someone is getting as val underscore val. I think you might have missed it. Okay, so it will show the, yeah, you can check it out whether your code is similar to this, or okay. So now, if you see, you are getting the sensor value, right? Okay. Okay. Uh, Whether your code is similar to this, or you have any changes in the code, you can just check it out now. Or what I can do is I can just copy it and go on it. Yes. First, you need to switch on your simulation, because before simulating it, it will be in its default state. Like, you can't change the values of the potentiometer. So it's always better to start your simulation, and after that you change the values. So that is the right way. Okay. Okay. So what I can do is, yeah, what I can, yeah. So, okay. So now what we did is we are reading the potentiometer value, correct? So for now we are just sending the data. Okay. So if you want to change the potentiometer value, so what you can do is we can just click on this knob. Okay. So there, in the knob, if you see clearly, there is a 5, 1, 2, 3, 4, 5, 6, 7. There is 7 circular marks, correct? So you can click nearby those marks, okay, anywhere. Like if I click here, it will change it here. If I click the center one, it will change the center, like that. So that's how you change the potentiometer value. Okay. So coming to our thing. So now we successfully taken care of this digital input, like we were sorry, analog input. So we were able to record the analog input that is coming from a potentiometer. So now what we'll do is we'll have a digital input, not an analog. So we will try to read the digital input. So for that, what I will do is I will just stop the simulation for now. Okay. So one thing about this Tinkercad is if you want to do any circuit change in the drawing board, you have to stop your simulation. Okay. So because during your simulation you can't change the circuits. Okay. So once I stop my simulation, I will just go. Uh, what is it? I'll just minimize my code editor. So I have the list. Okay. So for digital input, what I can go for it, I can go with PIO sensor, because as we discussed yesterday, PIO sensor is one of the digital input sensor. Okay. So what I will do is I will just drag it here. So for PIO sensor, so we can see only 3 terminals are getting out. So we will see what are the terminals. So if you see the pin terminal, 1 is signal, and 2 is power, and 3 is ground. Okay. So again, we'll do a quick recap. So based on the signal. So in order to measure it, what I will do is I will connect to pin number 2. Okay. Since it's a digital input, since the sensor output is digital, so I can use any of the digital IOs that are available in the Arduino. Okay. So for now, I will just connect it to pin number 2, and for the power, again we need a 5 volt. So most of the sensors will work with 5 volt. So if it is not 5 volt, then the vendor will be specified with respect to the voltage levels, whether it is a 5 volt or 3 volt or 12 volt, like that. Okay. But most of your sensors will work in 5 volt, so you can just connect it to 5 volt. So I'm connecting here. Okay, it's connected. And the last one is ground. So ground again. Okay. So I have connected. So once after connecting it, I need to change my code, correct? So for this, what I will do, I'll just go back to my Arduino editor. So with the present code itself, I will just add on the digital side. Okay. So what I will do is I will again I will give a variable for my PIR module. So for that, PIR sense. Okay. So which is at pin number 2, and one more variable to store the value. So PIR data is equals to, sorry, PIR data. Okay. So now we are given some variables for our pins and the data. So as we discussed earlier, since this is a digital input, so we have to specify the pin number and the pin function in this void setup. Since it is not a dedicated one, it is a variable one, so you have to mention the pin format. For that, what I will do is I will just type pin mode under the brackets. I will just name it as PIR. Since you can just write it just 2. Okay, you don't require a D2, uh, because if you see the Arduino, so there is just a numbering like 0, 1, 2, 3. So you can just type it as 2. D2 is not required. So what I will do is PIR sense underscore, I will name it as input. Okay, so this is the one, and again I will carry out the same here. PIR underscore value is digital read of my PIR underscore sense. Okay. Yeah, this is the keyword from the. Okay. So for this, again, what we need to do is we need to we'll push out the data from the microcontroller to our system. So for that, again, I'll just have a serial print of PIR value and one more serial print ln to display my PIR value. Oh, sorry, man. Yeah, it's PIR data. Yeah. PIR data, and here also I will change PIR data. Okay. So now, so what I am doing here is I am sensing both my analog and digital both. So there's one more there's one more keyword which is used to have a delay, like in order to maintain a delay in your execution. Okay, so the keyword is named as delay underscore. So inside whatever the number that you are giving, it will be counted in terms of milliseconds. For an example, if you write delay of 1, it means uh, the execution will have a delay of 1 second. Or if you type 100, sorry, 1 millisecond. If you type 100, it is 100 millisecond. If you type 1000, it is 1 second. Okay. So for now, what we'll do is we'll have a 100 millisecond delay of execution, just to make sure that everything works proper like that. Okay. So once you're done with the code, go with verify, like compile it. Yeah, it's saying there is no error. So I will just copy it, and then I'll open my code editor and things such as. Yeah, I will just remove the previous code and I will drop out the new code. Okay, so if everything is proper, I should get what we expected. Okay, so once click on the simulation, yeah, it's initializing. So in meantime, what I will do is I will just zoom out the circuit. Okay. Yeah. Okay. So yeah, the simulation is started. So if your simulation is started, then we should get a welcome note here saying that system is on. So since it is a cloud-based tool, so we will experience a lag. Okay, so we are seeing this system is on. So that is the indication that your system is active and your communication is also active. Okay, so if you see here, you're getting a data like potentiometer value, like there is an analog value, and PI value is 0. That means your PIR module didn't detect any change in the motion. Okay, so in order to activate the motion, what you need to do is just click on the PIR module. Okay, there you will get a what do you say, a vision kind of a view once you click on the PIR. Okay, which represents that the PIR module currently is focusing on that particular circular point. Okay, so in order to create a motion in the behavior in the field, what you can do is click on the circular one and just move on. So what you'll do is your PIR will be detected, that shows the red indication in the PIR module, and your sensor value also changes to 1. Okay, so that means that your PIR is detecting some motion in the field. Okay, so once after it detects for some time, and after again it goes back to its previous, like its normal state. So if it goes back to its normal state, your PIR value again falls back to 0 because there won't be any motion. So yeah, if you see here, the PIR went back to its nominal because there is no more motion in the field, and your PIR value goes back to 0. Okay, so if you follow the same, I think you people also getting the same value. So let me know, like, if you have if you are facing a different behavior in your sector, or else we can move on with the next. Uh, I think some I'll just what do you say? I will provide all those information at the end of the section. Okay. So in between, will just focus on the simulation. So if you people have any issues with this, just let me know. We can solve it, or we can move on with the next concept, analog and digital output. So till now dealing with analog and digital input. Yeah. So the basic principle of PIR is its abbreviation is passive infrared radial sensor. Okay. So what is the PIR sensor basically does is it will just check for the infrared waves that getting emitted by by the object. Okay. So if there is a motion, like if there is a motion in the field of view, there will be change in the what do you say change in the infrared waves that is emitting by the object due to the change in the motion. So at the time the PIR will sense those anomalies, and it will alert the user that there is some motion happening in the field. Okay. So if your PIR value is always zero, that means there is no motion. If you if you look into my serial monitor, here also the PIR value is zero because there is no motion according to its PIR, because the circle the round the circle in the field of view is static. So if you move the circle, like by clicking on the circle and just pulling it left or right or top or bottom, your PIR will detect it as a change in your change in the motion. So that time it will indicate the user uh, saying that there is some motion in the field, and the value will also raise to one. So if you are doing the same way what I'm doing, I think you people should get should see this behavior. So if this is done, okay, if you're getting the expected output, then we will move on with our next topic, that is digital input and the analog, sorry, digital output and analog output. Okay. Okay, so okay, why you are observing that anomaly is because whenever there is a motion in your PIR sensor, okay, so it will sense for certain time, okay, certain period of time. So like say when there is a motion observed from the PIR sensor, the sensor will be inactive for few seconds. It won't because it will just scan for whether is there any other motions that is happening, or is there any other motions that is not happening, like that. It's like it will be sensing for few more seconds. So that's why your PIR value will be showing one for sometimes. After that it will go back to zero. Okay. So yeah, for now I will stop the simulation. Okay. So coming to our digital and analog output. Okay. So what we can do is I'll just okay, wait, I will show up. Yeah. So I'll just minimize this. What I can do is I can just type it up, copy and paste it in the chat so that I think it should be proper. Yeah, it's proper. Yeah. So here you can just uh, have a cross compare, and or you can just copy it and paste it on your code code window. Okay. So yeah. So now we'll move on with digital and analog output. Okay. So I will just minimize my code window. And for okay, so for analog and digital output, so what we can do is uh, so a simple way for representing a digital output is by using a LED. Okay, I will just use one LED. um, and a resistor. Okay, to limit the current flowing to the LED. Okay. Sorry guys, there's some lag in the. Okay. So this is my digital output, and for analog also what I will do is I will use the same LED. Okay, but I will show you how to differentiate it, like how to use the LED, use an LED as analog and digital. Okay, so I'll just pop it up. So what I will do is I will just take any of the available GPIOs for this. So again, click, click, and click. Yeah, I'll just use 8 and 9 for my outputs. Okay. So one of the ends I connected to the GPIOs. So so other terminal should be connected to the power supply. So what I will do is I will just drag it out. And, okay, I'm going to bring it. So I will connect it to a 3.3 volt supply. Okay. For now, what I will just connect it to 3.3. So I don't want 5 volts since our LEDs will work with the 3.3 volt itself. Okay. So what I will do is one more. I'll just connect it to nearby. Like what you can do is you can just pick it up to a same anode pin so that it will have a proper connection connectivity. Okay. So here what I'm doing is I'm just using LEDs to represent my analog and digital output. Okay. So this is my circuit. What I can do is we can jump into our editor, and we'll have. I think we don't require any what do you say, any extra variable for our output. So we can use the same like PIR data and pot val as our output. Okay. But what we need to do is we need to mention the pin that is used as output. So I have taken 8 and 9. So I will mention 8 and I will name it as output. Okay. And pin mode 9 comma output. So I just taken it, mention it as output. Okay. So we are taken pin 8 and 9 as out, like we defined as an output. So here what we can do is we can consider pin 8, like the LED connected to pin 8 will be a digital output, and the LED connected to pin 9 is an analog output. Okay, I will mention it here. Digital output and analog output. Okay, so uh, so in order to have a proper digital output, okay, so we will define what is the default state of that particular pin. Let's say whether the pin 8 should be 0 or should be 1 at the start of the execution. So for that, what we'll do is we'll use a keyword called as digital write, which is nothing but uh, writing the data to particular pin. Okay, so this one will have syntax of 8, that is the pin name, and what you're going to write, whether it is high or a low. Okay, so for now I am mentioning it as high. Why? Because since my pin 8 is connected to cathode pin of the LED. Okay, so high is nothing but it is off. Okay, because your 3.3 volt is coming to one of the terminal, and your pin number 8 is also having a high voltage at the another terminal. That means your LED is in reverse bias, so it won't go. So that should be my default state. And the analog output, I'm not going to define, because anyway whatever the value that is presenting at that particular output should be my analog output. Okay, so coming to here, what I will do is I will just write digital write of um, digital output of pin number 8, comma PIR underscore data. That means whatever the data that is coming out from the PIR, like coming out of the PIR signal, I am just sending it to the LED, just to represent my digital output. The similar way, what I can do is for the analog output, I will just write PIR comma 9, digital write of 9, comma my pot underscore val. Okay, so what I am doing it here is I am just pushing out the analog data, that analog value that is read at the port analog input. I am just pushing out the analog. Okay, so this is this is how you will be, what do you say, you will be defining your output devices. Okay, so once after you are done with the code, or start to build, and you'll find if there is any error in the code. Okay, so looks like there is no error in the code. So what we'll do is copy it and open our code simulator, and we'll erase the previous, and I will paste it on you. Okay, so so I will paste it up, and I will start simulator. Uh, okay, so uh, okay, so someone has mentioned yeah, whatever you mentioned, it's correct. Yeah, instead of digital write, we need to do an analog write, since uh, that whatever the data that we are pushing out to the pin number 9 is completely analog. So we will change it to analog write. Okay, so analog write of 9, comma. So I will I will copy the new one. I'll stop my simulation, and I will stop. Yeah, and again I will start. Yeah, sure. I will just paste the code in the chat. So once we get this out. Okay. So if you see here, the system student click. Okay, system is on. So the PI value is 0, and the potentiometer value is around 123. So if you see here in the LEDs, so both the LEDs are on. Okay, so this is why, because the PI sensor uh, sending a value 0. which means it is sending a value 0 means your pin number 8 is also 0, which makes the LED to work in forward bias. That's why you are able to see the glow of an LED of the LED. Okay, so the pin number 9, like the LED that is connected to pin number 9, has a analog voltage of a value 123. Okay, so it's lesser than the 3.3 volt. So that's why your second LED is also glowing. But you can see the difference if I just change the potentiometer value. Okay, means the intensity of the LED goes, the intensity of the LED of change. Okay, if I'm not able to see, I will just move it to higher one. Okay, so you can see it here, like it's almost off, switched off. Whereas if I change it to lower one, like, yeah, you can see the change in the brightness. Okay, so that's how this analog output works. Whereas the digital, okay, I will just create a motion in my PIR module. Okay, so motion is detected, your PIR value, wait a second, your PIR value is raised to 1, and you can see the LED is off. Okay, so once your PIR motion is nominal and PIR value stops sensing it, you are again the LED will retain its previous state. Okay, yeah, you can see it's a complete off now. You might experiencing some delay because of this online simulation. Okay, so but if you rig up the circuit in real time, you will get to know. You can see the differences at that point without any delay. Okay, so now your PIR sensor is going back to normal. So your LED is also coming to its normal state, that is high. Okay, so that means that your the code is proper. So okay, so I will share the code in the chat so you people can walk through the code. I can try it out. Okay, so if anyone is having any issues, then let know. If anyone is facing any sort of issues or any code compilation error, just let me know. Okay, so now I will stop the simulation. Uh, Anyone got any output? Okay, so if you're getting it proper, then yeah, it should be proper. Okay, so next what we'll do is we'll have a quick interfacing of motor. Yes. Yes, whenever the PIR value goes to 0, the LED will be on, because the LED will be in forward bias. So yeah, that's our observation. Okay. So next, what we'll do is we'll have a quick uh, interfacing of a motor using the motor driver IC, that is L29CD, that we discussed today. Okay. So for this, what I will do is um, I'll remove some of my I will remove all those LEDs. Okay. So because I want more Gpios for this interface. So I will just remove it out. Okay. So I think I got it. So next, what I want a motor, a normal motor, hobby gear. Okay. Okay. So this is a motor. So while interfacing, like when you want to interface a motor with your Arduino using this L29 3D motor driver. So for better understanding, what we can do is we can just check online, like what is the pin notes of L29 3D, like which is the input and which is the output. So if you Google out, so you will get detailed explanation. Okay. So if you see in this image, so they are telling like pin 1 is nothing but enable, and pin 2 and 6 are the inputs. Sorry, 2 and 7 are the inputs, and pin 3 and 6 are the output. Okay. So what we will do is we'll just pick up exactly as mentioned here. We'll just go back. So I think you people will be knowing the pin 1 marking is indicated by a circle or a notch in the IC packages. Okay. So this enable one. So what I will do is I will just keep my enable always switch on. Like I don't want to control the enable separately. I will just keep it as high always. Like my motor driver will be active always. So okay. So this L293D, what do you say? L293D interfacing will work at 5 volt level. Okay. So don't connect it to 3.3. So always connect it to 5 volt. Okay. So uh, next pin is my input. So what I will do is I will take pin number maybe 11. So this is in here, but so I will take pin number 11, and this is the output. This is the ground. This is the ground. This is the output, and one more. Yeah, this is the input. So what I will do is again pin number. I'll connect it to pin number 6. So this nearby, and yeah, the output. What I will do, I will just connect it to one of the terminals, since your motor is not a polarity based device, so I will connect it to any of the terminals. Okay. And one more output. Okay. So there are 2 grounds. What I will do is I will just short this both, and I will take a common from one of the pin, common wire from one of the pin. Okay. There's one ground near pin number 13, so I will connect it to the ground. So halfway done. So there's one more, the power 2. Okay, so what is power 2? If you go to power 2 means this is the VCC2 that they have given. Okay, so if you check some other like wiring diagram, what is it VCC2 is exactly. Okay, so yeah, here they are mentioned. So VCC2 or VS is nothing but the power that is supplied to your motor drivers, sorry, for your motors. So it will be higher volt, like 12 volt. So what I will do is, wait, we'll check for a 12 volt or a 9 volt battery will also work fine. Okay, I'll just rotate it. So if you want to rotate any components in the Tinkercad, you can just press R in your keyboard. It will rotate for 15 degrees. And you can make it look. Okay. So here there's a positive terminal. I connect it to yeah, and negative I need to connect it to ground. Yeah. So yeah, this done. Like the circuit is done. So why there is no pins, no signals are connected on the other side of the IC is because as I discussed in this session, we know that L293D is capable of driving two motors independently. So how they designed is they designed like the one side of the IC will be used to control one motor and another side is another motor. Okay. So now our circuit is done. So what we do is we'll jump onto the code. Okay, we'll go to Arduino code editor. We'll do it in the same. We don't want any change. So but the pin 8 and 9 we removed it out. So we'll just comment it. Okay? And also here also the digital out and analog digital write and analog date will comment it. Okay. So now we are interfacing a motor. So how many signals that we need? We need uh, like two signals basically because one is connected on pin number 11 and one is connected on pin number 6. So we just require only two since the enable pin is already connected to 5 volts, so it's always on. The system is always on. So pin 11 and 6. So int, I will name it as motor underscore A to pin number 6 and one more int mode underscore B pin number 11. Okay, so I've taken two, and here what I need to mention is I will mention it as an output, that is digital output, that is pin number mode underscore A comma output. Okay, and pin mode of mode underscore B comma output. Okay, so okay, so this is the what is a basic pin definition. So I'm not doing any predefined, like I am not going to define any states before the start. Okay, so here uh, what I will do is I will just create a function name as motor. Okay, because the controlling is pretty much lengthier, so I don't want to mix up with our main loop. So what I will do is I will just name a motor function. So outside the loop, your functions uh, so your functions should be like function should be always outside of the loop. Okay, so void motor. So here I will define all the motor. Okay, so how to how to rotate my motor. Okay, so so someone asked for the circuit. Okay, once after I finishing the code, I will just move on, jump into the circuit. Okay, so it will take 5 to 10 minutes. Okay? So just bear with me there. So here what we'll do is we'll rotate the motor in one direction for 5 seconds. 5 seconds is pretty large. So, okay, for 2 seconds. And next what we'll do is we'll change the direction for 2 seconds. So 2 seconds forward and 2 seconds clockwise and 2 seconds counterclock. So this is what we are planning. So for that what we'll do is we'll just start with something called serial print line motor rotating in clockwise. I'll just name it. Okay. After that, since it is a digital signal, I will write. I should use the digital write of mode underscore a comma high means and more. I'll just do a copy paste. It will be okay. Okay. So here I will change mode B and make it is low because what is what this states means. So in this motor, so in one of the terminal I am giving high and one of the terminal I am giving low. That means there is a closed loop. It acts as a closed loop and your motor starts to rotate in one of the direction. Okay, so for how many seconds we plan for 2 seconds. So I will just make it 2000. That means it is at 2 seconds. After that I want to do it exactly opposite, right? I want to rotate in counterclockwise. Okay. So here what I will do is I will just swap the terminal. Like mode B will be high and mode A will be low, and it will be running for another 2 seconds. Okay. So this is the simple way of having a motor interface. Okay. So once it is done, I will click on the build for any errors or any other. So I think there is no error. Okay. So what I will do is I'll just copy the code, open my code editor. Okay, we'll erase it and I will load it. Okay, so my code is ready. So so you people have asked for the circuit, right? So you can now rig up the circuit shown in the diagram, shown in the drawing board. So in the serial monitor, if you see the serial monitor, like there is a lot of values already there. So I want to clear it. So what we can do is on the bottom of the serial monitor, there's the three tabs called send, clear, and there's some wave functions. Okay, so you can just click on clear to clear your serial monitor. So yeah, everything is gone. So now the code is ready. So we'll put on a simulation. So we'll see like how the motor works. Uh, okay, so there is a boom. If you see here, there is some what is it? There is some explosive type of image that is appeared. Why? Why is this? Because we forgot to provide a supply for our peripherals. Like if you see the pinouts, there's one more VSS. No, not less VCC. Actually, this L293D is capable of running from 5 volt to 12 volt. Okay, so you can give whatever the voltage in between you are having. The main thing that we forgot to give is there is one more power pin that is present in the L293D that we forgot to supply it. Okay, so that is VCC1, which is nothing but the supply that is required for your communication, like your internal communication. Okay, so pin number 16. Okay, what we'll do is we'll stop the simulation. Yeah, stop the simulation and we'll rig up this one. Okay, so what I will do is I'll just connect it to the enable pin, since enable pin is also given to 5 volt. So I will connect it to enable to have a quick connectivity. Okay. So our circuit is done. We'll open our code editor and we'll start simulation. Okay. So nothing is happened. See, if you see here, your motor is rotating. So what it is mentioning is it's going on count, like it's rotating in 244 RPM. That is what is it? It is rotating one direction. Okay. After 2 seconds, it should change its behavior. Correct. That is what our plan. Okay. Yeah, man. Just 1 minute, man. I will see whether it's rotating in opposite direction after 2 seconds. After that, I'll share the code in it. Or yeah, meanwhile also you can start coding it. Okay. So exactly 2 seconds means when your simulation times exceeded 2 seconds, it should change its direction. So that's what we have mentioned in the code. So we'll see whether it's sorry, it's happening as expected. So yeah, if you see, it's changing. Like it changed it to motor rotating in counterclockwise. That is, it's showing a 244 RPM means it's rotating in counterclock. So this shows that our code is working pretty much well as expected. So now you people can dig up and yeah, if any doubts or any anomalies that you observed, let me know. We can discuss it here. Okay. Okay, so I will show the code. Okay. So I haven't done any major change. Okay. So what we done is we just included one library called as motor. Sorry, one function called as motor, and we are defining its behavior outside the void loop. Okay. So this is your motor. So whenever you need a motor function, you can just include that function instead of having everything on the same code. I think I already shared the code. So okay, sorry, shared it to. I will share it one more time. Yeah. So this is the code. Just okay. Since your what is it, the numbers that is showing on the motor and representation that you are given goes complementary. Like for clockwise it's showing minus, and for counterclockwise it's showing plus. So what we can do is we can just swap the names. Like here we'll have counterclock, and here we'll remove the counterclock. Okay, and start simulating. Okay, just a moment. Okay, if you're seeing the whether you are getting the circuit, like okay, Okay, so this is fine. Okay, and the first pin of L293D is connected to 5 volt. Okay, so if you see it clearly, it will be connected to 5 volt pin.
Okay. Thank you, sir. I think we are at the end of the session. Am I audible?
Yes,
Hello?
yeah.
Yeah.
Yes, you're audible.
Yeah. Okay. So does anyone of you have any more questions? I think we can have a small Q&A session if anyone of you have any doubts or queries. I mean, feel free to unmute, or you can even just put it in the chat box. Okay, I guess there are no more doubts. Uh, Thank you, sir. It was really an insightful session. I mean, we already ran out of time, but I hope everyone have learned many things today. Without further ado, I would like to call upon Ruchita to deliver the vote of thanks.
A minute. Okay,
Yeah,
so many people are asking for the okay for a number, right? So what I will do is I will just put it out here, so that everyone can. Okay, so my active number is okay. So I will be more active on LinkedIn. Okay, so if anyone can catch up in LinkedIn, yeah, you can catch up. So my profile name is Anand M. So from that, my active email ID. Okay, yeah, this is a so yeah, this is where you can catch up with me. So I also have GitHub, but I don't use it regularly. So these things is fine. So if you want, I will post it in the chat. Okay, you people can feel whenever you have doubts, you can just catch up with. Okay, yeah, that's also easy. Yeah,
yeah. Thank you, sir.
yeah.
Yeah, the recorded session will be shared on the WhatsApp group. Uh, well, yeah. Without further ado, I'd like to call Ruchita to deliver the vote of thanks.
The Thank you for everyone. The 2-day workshop has come to an end finally, and we are really grateful for our speaker, Mr. Anand M, for sparing his valuable time on both the days and teaching us. And I'm pretty sure all of us have learned a lot, and we are going to have fun solving the problem statement, which will be released in the WhatsApp group. Thank you, Anand. It was really fun, really amazing, and really fun learning a lot of stuff from you. And thanks to all the attendees for participating in this workshop and making it a success. So yeah, the problem statement that you all have to solve will be put up in the WhatsApp group. So you'll be given 24 hours to solve, and please upload it before that. And then later the results will be announced. So make sure you solve it within the time limit. You upload the problem statement within the time limit. Once again, thank you, Anand, and thank you to all the participants for making this workshop a success. Thank you.
Thank you, guys. Yeah, thank you for the organizers for providing me the opportunity to teach something that I learned during your time. Yeah, thank you.
Thank you, Ruchita. Thank you, sir. Uh, I think we can have a small group photo actually. I request all the participants, to feel free to switch on their video so that we can have a, like a group photo session.
Okay, sorry, man. I don't have my camera. Like in my laptop, my camera default like it's plugged out. So I don't think I will be able to open.
Okay, that's all right, sir. Okay, what about other participants? Guys, please feel free to switch on your videos.
Thank you so much for joining.
The problem statement will be given in the WhatsApp group, will be sent in the WhatsApp.
Okay, if nobody has any questions, I think we can end the meet.
Yeah, if anyone has any clarifications, then we can have a talk. Otherwise, we can conclude in the meet. Okay.
Then
Shayan, your voice is breaking.